Hi, this is Andra Joni. This is the presentation regarding Big Data Assignment 2. So for that, we need to build an R tree. So in this, we have assumed B is equal to 4, and we have like two classes like node class and R tree class. And in node class, we are declared many variables, and first we have to define the NBR perimeter of the NBR, that is a half perimeter. And for that, we just added the length and breadth of the rectangle, and then we have to check whether it's an overflow. For overflow, we need to know the length of the data points is greater than b. If it is greater than, then it will overflow, and else means if it is like a child node, we need to check it for as well. And then we have to check whether it is a leaf node, and how to check a leaf node and a parent node. Leaf node, the data points should be equal to zeros, and for parent node, the root node should be 0. And in the class R tree, we have defined many functions called insert data points, and etc. For insert function, we are inserting many points into the R tree, and in that we are calling the insert points. For insert point, we need to check whether it is in insert point is for inserting the data points into the nodes, and we are appending the data points into the data point list that we have created, and then we are updating the NBR by choosing the data point is less than the NBR point or not. And next is for inserting the child node. For inserting a child node, we are inserting the nodes into a child node list that we have declared. And again, we are assigning the child node into a parent and updating the NBR here. And to handle, so whether we need to check for inserting, we have a method called overflow, and overflow method we have explained above. And for overflow, we need to handle the overflow. So for handling the overflow, we are defined the functions here. For that, we need to split the node into node 1 and node 2 by calling a method called split node. So in split node, we are doing is that we are declaring two nodes like split node 1 and node 2, and assigning the class node to that split node 1 and node 2. And we are we are doing separately for like leaf node and side node. For leaf node, we are taking the length of the leaf node, and we are sorting those data points in x and y coordinates. And in that, we need to according to the b that we have defined, b is equal to 4, we need to check whether if it is like between, we have to do it according in a way that b is between 2 to 4, like here. For that, we are taking from the second, iterating from the second to the middle of the uh, a length, that is, and we are assigning those into the n1 variable node. And same is for the second half, we are dividing it into from the half to the length of that node, and we are assigning it to n2. And then we are just comparing the best parameter we have declared. It's a large sum, we are just giving a random large value to that and comparing the NPR perimeter, and we are just assigning the n1 and n2 to split node 1 and node 2. And the same case for like child node as well. But here we are like taking the x1, x2, y1, y2 for sorting the x and y coordinate, and the same process we are doing here. And then we are assigning the parent to the child node as well. So in split method, after the split method, we are coming inside the handle method and handling it by splitting the node. And for that, and then we have to do it for parent variable and the internal variable separately, and inserting the side node and data points inside the node. And in the main function, next is the update query. In the update query, we have to check whether it is a leaf node or a child node. For leaf node, we are just assigning the coordinate points inside x and y. And then for child node, we are taking x1, x2, and y1, y2, and taking the minimum x and value as well. And in the main function, we are taking the time, a sequential time benchmark with the start time and end time by calling this insert method and the tree construction. And the total time is calculated by subtracting the end time and start time. Then we will get the sequential time. And for the running time, we are taking the average with the 200 query data range. and we are outputting it into a file called output.txt. By running the artery file, we will get the artery is constructed and our output will be sequential time is this, and running time will be like this. And this is a report that I've created for the assignment too. So I have like all the the environment of my system and the requirements and all the explanation of classes and functions. Then I've like establishment of artery with an example, example provided in the question, assignment question, and the divide and conquer method, everything. That output screenshot is provided in here. And I will put the link of the YouTube below the report as well. And thank you for that.